In this lesson, we're going to be factoring polynomials. First thing you want to always do whenever you're factoring polynomials is factor out the GCF, greatest common factor, if it's possible. And then next you want to check the number of terms in the polynomial. If there's 4 terms in the polynomial, you want to factor by grouping. If it's a trinomial with a lead coefficient of 1, you want to go ahead and just go straight to the 2 sets of parentheses and factor it that way. If the lead coefficient is something other than 1, then you want to factor by grouping. If the lead coefficient is just 1 in a trinomial, you're just going to factor as follows. The only factors of x squared are x and x, so they'll go in the front of the parenthesis. Only factors of 2 are 1 and 2, so they'll go in the back of each parenthesis. And then the constant term is positive. The 2 is positive, so that lets you know that the signs in both parentheses are going to be the same. And then we look at the middle term, the linear term. The linear term is positive, so that lets us know that both the signs are going to be positive. And then you should check yourself. X times x is x squared. When you multiply the inner terms, you get 1x. When you multiply the outer terms, you get 2x. 1x plus 2x is 3x. And then multiply the last terms. 1 times 2 is 2. Whenever you factor a trinomial that does not have a lead coefficient of 1, you want to factor by grouping. So we have this trinomial. First thing you want to do is multiply the quadratic coefficient by the constant. 9 times 10 is 90. And then you ask yourself, what 2 numbers, when we multiply them, give us 90? And when we subtract them, because that last term, the constant, is negative, that's why we're saying looking for 2 numbers that we subtract to get the linear term or the linear coefficient. And then those same numbers we need to multiply in order to get that 90. So those 2 numbers are 9 and 10. 9 times 10 gives us that 90. And then 10 minus 9 gives us 1, which is the coefficient for that linear term. All right, so once we've determined that those 2 middle terms are 9 and 10, we just add the same variable that's on the linear term to both of those numbers. And in order to get -1, the 10 needs to be negative and the 9 needs to be positive, because negative 10 plus 9 will give us -1. Now we factor by grouping. So if we group the first 2 terms together, we can factor out a 9a. That'll leave us with a plus 1. For the last 2 terms, we can factor out a -10. That'll leave us with a plus 1. And now we have 2 terms with the greatest common factor of a plus 1. So we can factor out an a plus 1 from the 2 terms, and that will leave us with 9a minus 10. If you have a difference of 2 squares, you just write whatever the base is for the lead square in the front of both parentheses, the base of the trail square in the back of both parentheses. One of them should be positive, one should be negative. Difference of 2 cubes. This is the pattern used for a difference of 2 cubes. It's always a binomial in the front. The base of the lead base, and then the same sign, if it's a difference of cubes, then that binomial is going to be negative. And then write down the base for the trail term. And then you're going to have a trinomial. That binomial is going to be multiplied by a trinomial. It's going to be whatever that first base is squared. And then go ahead and fill in the last term in the trinomial by squaring the other term or the trail term in the binomial. And then to get the middle term for the trinomial, you just multiply the first and the last bases in your 2 cubes. Sum of cubes is exactly the same as difference of cubes. The only difference is the signs. The signs for the binomial is always the same as the sign that separates the two cubes. And then the sign for the middle term in the trinomial is always the opposite of the sign in the binomial. All right, first example, we've got 4 terms, so we want to factor this by grouping. We can factor out a 4x squared from both of those first 2 terms, leaving us with x minus 7. Then we can factor out a 3 from those last 2 terms, leaving us with x minus 7. Now we have 2 terms with a GCF of x minus 7, so we can factor out the x minus 7 from the 2 terms, leaving us with 4x squared plus 3. We've got 4 more terms, so we're going to factor by grouping again. We can factor out 3x squared from the first 2 terms, leaving us with x plus 2. And then we can factor out a negative 75 from the last 2 terms, leaving us with x plus 2. Now we've got 2 terms with a GCF of x plus 2. So we can factor out the x plus 2, leaving us with 3x squared minus 75. Now, you should be able to see that we can actually factor out a 3. We probably should have started, followed the rules and factored out the 3 from the very beginning. That should have been the first thing that we did, but as long as you catch it before you're done, factor out the 3, and we've got x squared minus 25. X squared minus 25 is a difference of 2 squares. So if we factor a difference of 2 squares, we're going to go ahead and write our 2 parentheses. The only factors of x squared are x and x. And the only number that you can multiply by itself to get 25 is 5. And then one's positive, one's negative. Next example, we've got x cubed minus 64x, so we can factor out an x from both of those terms, leaving us with x squared minus 64, which is a difference of 2 squares. So when we factor the difference of 2 squares, we can start with the x's in the front of the parenthesis. Square root of 64 is 8, so 8 goes at the back of both parentheses. One's positive, one's negative. And now we're going to factor out an x from both terms. That'll leave us with x squared plus 64. Now, this appears to be, it is actually a sum of 2 squares. However, you cannot factor a sum of 2 squares. You can only factor a sum of 2 cubes. So we factored this one as far as we can factor it. We've got x cubed plus 64. This is actually the sum of 2 cubes. And the number that we would have to multiply by itself 3 times to get 64 is actually 4. All right, so now we know what the bases are for both cubes. So we can go ahead and start to fill out the factors for that sum of cubes. The binomial is going to be just the bases of both cubes, so x plus 4. And the first term in the trinomial is going to be the first base, or the lead base squared, which is going to be x squared. The last term in the trinomial is going to be the trail base squared. 4 squared is 16. And then the middle term is going to be the product of the 2 bases. 4 times x is 4x. And it's always the opposite sign of the binomial. And then you should check to see if that trinomial can be further factored. However, there's not 2 numbers that you can multiply that'll give you 16 and add them to get 4. The only factors of 16 are 1 and 16, 2 and 8, 4 and 4. And you can't add any of those factors and get 4. So it's factored completely. Next, we've got this difference of 2 cubes. So if we go ahead and set it up this way, what we'd have to cube to get 8 is 2, and then x cubed is x. We would have to cube 5 to get 125, And then we would have to cube y squared to get y to the 6. So now we have the bases of both cubes. We can factor the polynomial. The binomial is just going to be the bases and the same sign that separates them. So 2x minus 5y squared. The lead term in the trinomial is going to be the first base squared. 2x squared is 4x squared. The last term in the trinomial is going to be the trail, the base of the trail cube. So 5 squared is 25. Y squared is y to the 4th. And then the middle term is going to be the product of both bases. So 2 times 5 is 10. X times y squared is xy squared, and it's going to be the opposite sign of the binomial. And then we should also check to make sure that we can't factor that trinomial any further. And I don't believe that we can. Next, we've got a difference of, well, we can factor out a y from both of those terms and a 2. So we can factor out a 2y from both terms, leaving us with x to the 18th minus 27. That is a difference of 2 cubes. So I can write them as the difference of 2 cubes. What I would have to cube to get x18 is x to the 6th power. Then I would have to cube 3 to get 27. So now I can write out my factors. The binomial is just going to be the bases of both cubes, x to the 6 minus 3. And then the lead term in the trinomial is going to be the first base squared. So x to the 6 squared is x to the 12th. The last term in the trinomial is going to be the last base squared. 3 squared is 9. And then the middle term is the product of the two bases. 3 times x to the 6 is 3x to the 6. And the middle term is always the opposite sign of the binomial. And then lastly, we've got a trinomial. So first, it has a lead coefficient of 1. So we can go ahead and write out our parentheses. The only two numbers that we can multiply, the only number that we can multiply by itself to get x to the 6 is x cubed. So that's going to be in the front of both parentheses. And then the two numbers that we multiply that will give us 8 and subtract to give us 7 would be 8 and 1. Because the middle term is negative, the bigger of those two factors should be negative. So the 8 should be negative and the 1 should be positive. Again, that negative 8 in the trinomial lets us know that the two binomials have different signs. And then now in the front, we've got a sum of 2 cubes, and in the back, we've got a difference of 2 cubes. If we factor the sum of 2 cubes, we get x plus 1, x squared, plus 1 for the last term in the trinomial, and then negative x for the middle term. Then when we factor the difference of 2 cubes, the x cubed minus 8, we get, it would be x cubed minus 2 cubed, x cubed minus 2 cubed. And so the binomial would be x minus 2. Lead term in the trinomial is the first base squared, so x squared. Last term is going to be 2 squared, which is 4. And then the middle term is going to be 2 times x, which is 2x. It should be the opposite sign of the binomial. And this is what it would look like, all the factors aligned.